Welcome to yet another class. I'm Dr. B. Today we are going to be looking at something very familiar, and that is the kinetic molecular theory of gases. So we are going to look at the kinetic molecular theory of gases. We are going to look at that. The kinetic molecular theory of gases. Now, it's interesting to know that the gas is not just what you see as just air, but the gas is made up of other type of particles, either it's atoms or molecules. So when you look at a gas in a cylinder, for example, or if you can collect gas, for example, and you take a look at it, it is not just the air that you see around you. It is made up of some atoms or some molecules. Whether that gas is coming in from the same type of atoms or different type of atoms, but the important thing there is that this gas you see around you is made up of other particles together called atoms or even molecules. Now, to be able to understand what the molecular theory of gases is talking about, there will be need for us to put down a diagram that can guide us. But let us know that the kinetic molecular theory of gases explain gases from two different dimensions, and one is the assumptions that were made, and two, the postulates. Postulates that were made were raised from the assumption. Now let us put down this diagram. Let's say we have this diagram. Okay, let's say we have this this diagram here. Okay, let's have this diagram here. Now you can see some dots somewhere here, some dots around here, around here, around here. These dots can be facing different directions. Okay, can be facing different directions in this way, but this probably this way or something. Okay, so now when you take a look at this diagram that we have here, you can see that we have tiny dots inside this particular container, and what we have inside this container is gas. Now, following the assumptions that will lead us to the postulates of the molecular kinetic theory of gases, we will be able to explain what a typical gas seems to look like. Now let's look at the assumptions first. Let's look at the assumptions of the kinetic molecular theory of gases. We'll discuss the assumptions on the basis of one particle. We'll also discuss it on the basis of point masses. Okay, we'll also discuss that on the basis of negligible volume. Okay, and then we'll also look at it as a, let's say we'll also look at nil force of attraction. Okay, we'll also try to look at it on the basis of particles in motion. Okay, and then we can also consider volume of gas as one of its assumptions, looking at volume of gas. And then we look at kinetic energy. Of gases. Now, these assumptions of the kinetic molecular theory of gases were based on this. In fact, there are up to 10 different assumptions where we have 5 postulations that were drawn from the assumptions of the molecular kinetic theory of gases. And these assumptions try to explain what a gas looks like. We know what liquids look like. We know what solid look like. A gas, what does it seem to look like? Now, if we look at the particle, if we take the particles first, it is important for us to know that for every gas, there is a large number of what particles that make up that gas. For every gas you have in a container, for every gas you have anywhere, there is a large number of particles. Either they are in the form of atoms or in the form of molecules that made up the gas. That was the very first assumption. And that assumption was very, very paramount. Was interesting to understand that it's not just about the gas that we see around, but the gas which you see and call gas that looks like an ordinary air possesses what? Large number of atoms and or molecules. Now, the second assumption of the kinetic theory of gases or point masses, it believes that for every gas, there are particles which we term molecules or atoms that looks like point masses. They look like they seem to look like a dot, okay, like a dot or a point on a paper. So if you take a look at this container, for the gas that is inside this container, there are what? Particles that seem to be like a point on a paper. There are particles that seems to be like what? A point on a paper. So for every gas, it does not only matter that it possesses what? Large number of what? Particles called atoms or molecules, but it also does what? Possesses these particles in point masses in form of dots or points at particular positions of the container. So if you look at what was drawn here, you can see a dot, a dot. These are what? These are all what? These are all gas particles. These are all gas particles. So the point masses here in this assumption, in the assumptions of the molecular theory of gases, is that for every gas there exist particles that look like what? Points or dots on a paper in that container that it exists. Now the third assumption was negligible what? Volume. Now I want us to know that if you take a look at this container where there is gas inside this container, the volume to which the particle of the gas possess is not the same as the entire volume of the container. The volume to which these individual particles, these points of gases possess inside there, is much more smaller than the entire volume. So if you take a container and fill gas inside, where you have the various particles of the gas that form the gas in that container are just at particular points where their volume cannot be compared to the empty space you find in that container. Therefore, their volume are what? Negligible. So you cannot ordinarily measure the volume of these particular particles of gases inside there, because the volume to which they occupy at that point is quite smaller, very tiny, so negligible compared to the empty space that houses them. So the assumption was that what? Was that the volume of what? The volume of each of these particles of gases in the container to which houses them is what? Negligible compared to the entire space that the container carries. Now another one is the nil force of attraction. The nil force of attraction simply means that because this particular point, these particular particles of gases are far away from themselves due to the fact that they have negligible volume, they cannot possess any form of force of attraction or even repulsion among themselves. So gas particles, according to the kinetic molecular theory of gases, do not possess any form of attraction or repulsion among themselves because of their negligible volume. So they stay far away. They are far away apart. So it is difficult for you to drag them, difficult for themselves or their particles to drag themselves closer. It's also difficult for them to even repel themselves. They cannot attract. How do they repel? Now the next one is the particles in motion. Yes, because these particular gas particles are far apart, they have so much space enough to continuously be in motion. So one of the assumptions of the kinetic molecular theory of gases is that gas particles in the container to which they are what? In a constant motion, even though their motion is in straight lines. And this constant motion gives them the opportunity to either strike themselves or the walls of the container. So, according to the kinetic molecular theory of gases, gas particles at their various points where they are in a constant motion. And because they're in a constant motion, they have the ability or the possibility to strike themselves or the walls of the container to which they are. Now that is another assumption. Now another assumption is the volume of gas, volume of the gas particles. Remember that we have said before that the volume of the particles of gas at every point where they are in this container is negligible because it is quite tinier compared to the volume of the container that holds them. Therefore, it means that you can only decide the volume of these particular individual particles of this gas by looking at the volume of the container. So by that, the assumption is that a gas do not have a volume of its own. It only takes the volume of the container it is being used. So every gas you want to measure, it is possibly that its volume is proportional to the volume of the container. Now again, we look at the kinetic energy as another assumption. Now it is believed that because the particles of this gas in the container that is hosting them are in a constant motion, it means that they will possess kinetic energy. And the kinetic energy that they will possess will only be proportional to the temperature of these gas particles inside the container. So the assumptions were just in that way. So for every gas particle that is in this container will possess a kinetic energy on the basis of the fact that they are in a constant motion. That kinetic energy is only proportional to the temperature of the gas, not the container, to the temperature of the gas. Now those were the assumptions, or let me say those are the assumptions of the kinetic molecular theory of gases. Now how about the postulates? Like I said earlier, that the assumptions, the postulations of the kinetic theory of gases is drawn from the assumptions. If you don't understand the detailed explanation of the assumption, it becomes difficult for you to understand the postulations. Now let us look at what the postulations of the kinetic theory of gas is. Now one of the postulations is this. One of the postulations is this, that all gases possesses tiny particles called called atoms or molecules. That is one of the postulations, that all gases possess all gases possess tiny particles. That is, they are made up of tiny particles called Called atoms or molecules. So that is the first postulation, and that postulation is drawn from here. We said assumptions is that the gases possess particles. Am I right? Large number of particles. And the second postulation was that these particles are tiny. They are like point masses. they are like dots. Now, if you put these two together, they form the first postulation of the kinetic theory of gas, which says that gases possess tiny particles called what? Called atoms or molecules. And the second one is that the gases are in what? A constant what? Motion. That gases are in a constant what? Motion. Remember that we had said that when we try to look at particles in motion as its assumption. So you can see that one of the postulates is that gases are what? In a constant motion. And remember that why they are in a constant motion, it is because of the empty space, the large empty space they have, that makes their own volume negligible. So they are what? In a constant what? Motion. Now the third postulate is that they possess what? A kinetic energy. That the gas's kinetic energy is what? Proportional to what? The temperature of the gases. Remember I had mentioned that the gas's kinetic energy is proportional to what? To the temperature of the gases. Now, the next postulation is that the volume of the gases does what? Is proportional to what? The volume of the container. That is it. The volume of the gases is directly proportional to the volume of the container. So if you want to look at the volume of a gas, you can possibly look at that volume of the gas from understanding the volume of what the container that houses that particular gas. Now, and finally, if you look at the postulates again of the kinetic molecular theory, it aims at what? Forces of attraction. It makes us to understand the fact that there exists no forces of attraction between what? Gas molecules, and that allowed them to do what? To move by striking the container to which they are, or striking themselves. So you can see that the postulations of the kinetic molecular theory of gases were drawn from the assumptions of this same kinetic theory of gases. So before you be able to have a grip of these postulations, you must go back to understand the real interpretations of the assumptions of the kinetic molecular theory of gases. I'm sure that you have learned something today again, and do not forget that it is important that you support these lectures we're having here by simply going to my YouTube channel, Dr. B Chemistry Classes, and subscribe. Make your comments, leave your comments there in form of question or any other thing you are attended to. You go to my YouTube page, Dr. B Chemistry Classes, and follow. And also do what? Comment, share, and like. Until next time, it is